where increasingly students have tablets or Chromebooks that don't run the Java or web-centric. So I think that's a trend that's throughout education. That being said, NetLogo started in 1997. Was this the initial coding work? 1999, we were released 2 years to build the serious development and refinement. It's not possible to turn that around in one development and have NetLogo web be everything that NetLogo software is. So if you go to the NetLogo website, you'll see the kind of caveats.
And struggle to travel around in the network of words, and then sort of using that as a way of drawing words to be code as code or something like that. And so I really like the book a lot. So that's sort of but of course we also use it. I use it in the research and design, for instance. It's kind of really so yeah, I've been using it over the last years. I really enjoy it. I use it a lot. I think it is useful for a lot of things. And I always enjoy making people talk about it. So that's
I'm Sam, and it's kind of like confusing. I never used this kind of software before, but then once I actually know what to refine on the logo, it's kind of interesting to see like different, using like adding more factors and like using less factor, and how does it like affect the whole project. I love seeing like the inclination of like things happen in the logo. Yeah. So I'm currently a grad student.
And is there an area that you're interested in?
So I'm interested in like intersection between design thinking and construction. And my goal is to design like a tool for like any kind of initiatives using constructionist learning environment.
Okay. Hello, everybody. My name is Nat. And I'm Nat. And still, the last time I worked with my advisors and lab assistants on the learning project. It's aligned to model and how they learn for the children.
I'm Andrew. I teach in K-12 schools. I've been teaching variations of like kid-friendly programming environments since my first year teaching was in 2001. So I've gone through, I think, a fair number of iterations of these things, and like I've really reached a point where I'm finally happy with the kind of like the spread of tools that are available, except for the fact that every time I try to figure out how to build complex systems that are student editable, even though I don't expect them to be student designable, I feel like the overhead that I wind up getting into in something like Scratch is daunting for me, and that's since they're only really used to kind of block-based abstractive languages. I've always been looking for ways to. One I always talk about is I teach in Korea, so every kid lives in a 30-floor high-rise, and finally I've got a chance to you can put an elevator, like a bank of elevators there, and a bunch of floors, and have them actually try to think about what kind of logic needs to go into assigning elevator priority into buildings and actually make it not frustrating, because everybody is frustrated all the time. So like, I can't believe I'm on 9 and the elevator was on 12, and I pushed the button and it went right past me.
Right.
There's reasons for all of that, but they're not obvious. And trying to figure that out in Scratch in a way that kids could modify it without accidentally disconnecting the important blocks that break everything was really tricky. So that's
Did you succeed in the end?
I got one that I could work with, but I couldn't make one that was stable enough to give to kids to work. Basically, Scratch doesn't have a great version of the agent model. Like, you can make a clone of something, and maybe you can have clones of something that works through, as we were talking about yesterday, that work through cloud variables to give information back to the source. And it's always very fragile. It's not what it's supposed to be doing. So,
Yeah.
So that's what I'm looking for here.
Cool. Yeah. Nathan just walked in.
Oh, sure.
Are you going to stick around?
More than half.
want to take away, and we'll try to make sure that happens. So an elevator model, but
The basic idea, like, I would love to see or work through myself, like, the basic spin up of blend document, agents, behaviors, like the variables of both the internal variables for the agents and the external quantities that are tracked in the environment and interaction.
that would be a
Yeah, maybe if you wish. So, but I think maybe it could use it to simulation some model.
So to make virtual version of a robot.
No, it doesn't. It's just like some kind of the doing, the virtual doing
Oh, okay.
simulation. What would they be and how it can be.
For me, because I experienced NetLogo in the classroom, I actually wanted to, well, it may or may not be able to do this in this workshop, but I actually wanted to see how kids can actually use this in the actual classroom. Or like, you know, the future like closing workshop for like high school kids, like how would you approach it?
Okay. Much different. And so, depending on how it goes, the materials that I prepared were slight modifications to materials that I used 2 weeks ago with high school students. So, yeah. Yeah, so I think you'll get a sense. Any sense you get of starting from scratch and learn is what I would do. With middle school and younger students, I use a different approach, but high school students. What to look forward to as not what it develops. The other tool that's here is a Google site, and the reason I wanted that was I wanted you to be able to have access to handouts that I didn't want to print very often. But then also that I think it's really cool to share articles and exchange of things. But in this postings, in the ones that are postings, I think they're like blog posts. And so if you press the new post button, which would be the one that's here.
It's okay.
Can you read something?
No, but I know that I'm in the posting information for Wolf Sheep.
Right, so you would, for each blog post, you give a title, and ideally, since we're all logged into the same account, you'd put your mic on.
That then I have to, because I just copy it on the web.
Oh, you just paste it into it?
Yeah, or I could just do pen program and then save it.
It should be. Yeah, 'cause-
Amazing. Windows print screen.
yeah, try it.
Make it as So,
So Windows.
Let's see if when you add a file, or if you, here, here's another. Now we set my picture. Save it. So once did you succeed in adding that? And Sam, do you have an idea how you would change the language from? What are these three?
Insert.
So do you?
let me figure out how. Okay.
Well, always. Or you would solve it. So I've only got one person who posted.
That's
Actually, Yeah. Right.
Maybe we could pose for a really good picture, like
Yeah.
something like that, you know?
Yeah, always aim the camera away from the screen.
That's my actual first
Oh, that's your actual.
And Arthur's my middle name.
That's beautiful. I think you've seen it, but Hermes is a pretty cool name.
It's a pretty cool name, but it was.
If you had a computer, you could
I
share. Sam, that's okay. She's
Okay.
so when you. Two things that are called test and one that's also I can't read. Nobody's put their name in it. So when we're kind of doing this fluidly in the course of the workshop, put your name in the post so that we can. This is the downside of having given you not relied on having a Google account and just put one where the first name is construction and the last name is list. But yeah, put your name in the post and use descriptive titles. But this will be a place where when we post things, then you also can go and see what other people are doing as you're going. All right, so I think we're not that heterogeneous a group. I think we're all kind of starting from not huge regular people anymore that works with a small number of turtles. And so one of the things that we do is play games with applause or moving around the room and following rules that give rise to kind of surprising things. But I think maybe we should not do that. So in my list of things that I was in, I kind of my bag of tricks for the talk for not knowing what I would play if you don't understand some things as it comes up. And then the idea of agent-based modeling, where we were talking about how Brady was thinking about synchronicity. That's in a nutshell what agent-based modeling is. And so maybe we should just jump to playing around with what NetLogo is. I should maybe as a proxy for playing those emerging games. So when I said I went to a few high school kids in Chicago last week, there are birds like this in Chicago, and so it was part of their experience. It's also got a cool term, so these are starlings and the collective noun for starlings is a murmuration. So if it hits grass, it's going to turn it brown and eat it and get some energy. If its energy is a lot, then it's going to divide its energy in two and do something called hatching. Right? So what would that be? Baby. So it cuts its energy in half and gives half of its energy to the baby. Hatching one. It doesn't have double twins or anything. It has a single baby, which then looks in a random direction. And if it has less than zero energy, it does this mysterious thing called die. So it's kind of, this is its whole life, right? Everything about this turtle is expressed here, that it's going to have some active behavior, it's going to eat, it's going to have a life cycle of giving birth, and it might die.
There's no entropic decay. Like in an ideal food situation, that turtle is immortal.
Yes, it does not die of old age. I could add, it would be easy.
Yeah.
Now, if I wanted to make old age, let's see how this one works. And so, if I think about it from the single agent, it's just going to go in some direction and eat. So I might expect that this would look like, what do you think is going to happen visually in this world?
It's going to move very slowly because your randomness is. It's also.
The math here might be a little mysterious.
So it's these two parameters, a floor and a ceiling.
So this is the random 61, negative 32. So this
Is your default direction right or left?
I'm actually just changing my heading by an amount.
Okay, so 0 is here, 359 is there? Okay.
Yeah, so there are lots of ways to do this logic, and one is to say right a random degree and then left a random degree. I found some students hate that, and some students love it. So it's used, but the randomness was making you think it was going to be inefficient in covering graph, right?
And it's going to spiral in, it's going to keep making right-hand spirals. So
So you expect this guy to kind of eat its way like this?
no, more I think quadrant 1 is going to get harder than quadrant 3.
Okay, okay. Any other expectations? So one cool thing about it's going to do things, you're going to say things, and it's going to do things that surprise you. And that surprise is either going to be because you didn't say what you meant to say, or because the system is complex enough that it's not possible to predict it as a human. So those two kinds of surprise are different, and sometimes overlap. So let's see if we have any.
Deborah, were you going to say something?
Yeah, Deborah, do you have a prediction? Nothing.
It's the worst movie ever.
That is bizarre. Look, I promise that it's actually download from my computer to my computer. All right.
Yeah, I'm not the one with the broken video. Look at that.
Let me see if I can find this.
Really big deal.
Where is the NetLogo? Come on, man. Right. So that was an awesome comment. Let's watch it again. Tell me what you see. Like what do you see? What's the perception? Right, so if there's something circly about this, right, or ripply, that's not in any one of the agents' code, right? That agent lifecycle has nothing about circles, but the group is doing something circularly. Even individuals, if you were to stare at an individual, there'd be nothing circly about what they did. So it wasn't that you made a mistake, that I made a mistake, and I had some secret circle with my individual. But what did you say, Deborah, about the awe?
The ones that go inward, they're not there.
Circling comes from the fact that we've ravaged our natural resources and we don't expand, right?
You would see far less of the circle if the dead ones left corpses.
Yeah. And so we could change the model so that it didn't say die, but it said stamp die or something, right? And then we'd see dead ones.
Does the grass renew itself or no now?
Yeah, I didn't rules for them, so they didn't have rules.
Reproduces a lot faster than I expected. I don't know if they had energy to start with. I guess they get 5.
They get 5 for every time they get grass, right?
So it shouldn't take too long, but yeah.
So it should be every
That's energy.
Two, of course.
So if you, this is the video.
What's that?
I was going to say, like, if you modify the reproduction threshold, you might move to something that's slower and doesn't, like, it might produce more in, like, staggering.
Right. So, awesome. Parties that didn't come directly from the agents, but came from the interaction of agents or the execution of their rules. 2, that whenever we see one of these things, we always want to change it. Right? And 3, that those changes can make it into a different thing. Right? And so that's going to be one of the, so given only 2 hours, we're going to do some starting from scratch and file new stuff, but it's also going to be a lot of fun just to go into existing models and mess with it. That actually turns out to be a really generative thing to do, both for kids to work with their own, with their colleagues, but then also to work with the giant models. And while, as soon as there's a time when you guys are working, I'll find the real model of this and post it over to you. I maybe should say this for your benefit, Sam, that we're going to jump into the models library. I was thinking that doing living systems would be kind of fun, partly because if people are familiar with Logo is really, it's one of the kind of instant desires is to go beyond geometry to something that feels like it's alive. And so I suggested a bunch of models in biology, but it's also true that Logo's been used in kind of this wide range of things, including chemistry, computer science, physics. Robotics hardware uses based on social policy and people thinking about groups of people. And in general, the idea is that moving from other ways of thinking about aggregates, like this equation way of thinking, to the agent-based way of thinking, can change a lot about what order of things you learn, what's the order of things you learn in a discipline. So how late do you have, how far away do you have to push understanding of ecosystems in a deep way? Pretty far if you've got to know differential equations, not very far if you've got to know that a wolf wanders and looks for sheep. And so the difference is so extreme that it can change the nature of whole disciplines. And that's what some of my worry around. So what I thought we could do is have that little cycle we had where we saw a model, played with it, saw what its rules were, and then were surprised enough to want to mess with it. It's something we try out with full sheet, and then I sort of work on it a lot. Let's actually do something from scratch, just so that it doesn't feel like it's physics. So you've got yeah. If you just come in, join with somebody here, and we'll make something together. So if you go to that open. I keep thinking I can, and then it turns out it's scratch. So let's play a little bit. I wanted to sort of introduce you to the main characters of this, and we're really going to talk about three. Okay. So the first one is the turtle, and its friends, right? So there are going to be a whole bunch of possible types of turtles. Turtles are agents that move. The second kind is patch, which is an agent that doesn't. It can do almost anything. There are whole models that have no turtles and just patches, but they're ones where the interaction is with neighbors. A third one that we're not going to do a lot with, but are fun, are links. So you can create, if Arthur and I are turtles, you can create a link between us that would be itself a thing that has a life of its own. And that can be fun for understanding networks. It visualizes, does things like tells turtles to be born. Asks. And he does it nicely by asking. But he can also just use a word or create. And so the observer is kind of like us when we're not thinking like a turtle, but also has some basic.
One is the size of a patch.
That's right.
Yes, you can't really see the patches, but one is also the size that the turtle was that filled up.
Are they rectilinear? Are they like? Does the size of a patch?
I have a machine that does that, and so what I want to do is make a button. So if you go to any white space in your world here, and well, there are a bunch of different ways of doing this, but I'm going to do it by right-clicking in the open space. And I'll build a little menu of things I can add, and there are a whole lot of treasure trove things we can add, and we'll get to some of those later, but the first one was button, right? So boom. I've made a button, and it's like I'm making an automated control center, right? So I get all the same options that I had before. I can talk to different, this agents question. I want to talk to turtles, right? So I'm going to change observer to turtles. Right, so I'm talking to turtles. But I also want this to happen forever. Like I want to press the button once and have it happen, keep going. So if I click this forever button, then that would be what happens. If I didn't have forever button pressed, if I didn't have forever checked, it would happen once. And so then I could get my motion by clicking many times. But I really want to set it. So I'm going to do this first.
And you can also have it be a repeat subset, and would it then happen, would it do each?
I haven't introduced the notion of time yet.
Okay.
And so it would do this. I get this motion that's coming from my turtles going over.
Is that nothing?
Yes. That's a question. So now the first thing that happened, well, what happened was they came back. So mystery, that was another unexpected thing. Let's see what happened. So now I want to set up an experiment to understand how this world works. And so what I need to do is always make some turtles and then use this button. So I need another button to start over. And observer, a God thing to do, right? So this button is going to say create turtles. So I don't know how many turtles I want. This time I'm going to do a smaller number of turtles.
Okay. And then you need to like clear all. So
Oh, good point. That would have been a bug if you caught it before I ran it. That's cool. So in order to, if this button is going to be start over, I better do the other command that's in the vocabulary list about clearing all. So clear. So the two commands in this button are going to be clear all and create turtle set. And since I've got a mess here, I'm going to call that setup. Right, so what I did was, I left it talking to the observer, because I wanted to, this is my start over button. I said clear all, and create a certain number of turtles. And I gave it a name so that it was easier to read. And I gave it the name setup because I'm trying to get you used to the conventions of NetLogo. Setup is going to be one of the two main, the world gets cleared, I get turtles in the middle, and I'm ready to run my experiment. So now our question was, what is going on with this world? It's not infinite. And so how are the turtles going? So here's my first run in this experiment. So here's my, I wanna see if we can figure out what's going on here. So I've set up this experiment, watch what happens. In fact, let me do it like I did before. We can do it with any number, but I had a bunch. So let's watch the phenomenon and then see what we want to do. So I've set up this getting wider. And now I'm gonna slow down. So watch what happens when the turtles come to the edge of the world. Tell me what you see. What did they do? What's that?
no,
Turn back?
not turning because the colors change. That yellow one that's on the left used to be on.
Yeah, you want to, the great thing about, yes, time index.
No, you can't.
Reverse time. No, I
That's
can't
what model
reverse
runs,
time.
yeah.
But I can make things go slow.
Oh, yeah.
All right, so let's watch it again. And now I'll slow down. What happened?
take on the origin. They swap the signs on both their x coordinate and the y coordinate, but they also gain direction.
Okay, so there are two theories I think here. One is,
Abstract.
and the other one is what happens on a pool table, that they bounce, right? So we have two theories of the world, right? And so we're now like in medieval turtle Europe, and we believe that there are dragons at the edge of the world. And so we're going to send Christopher Columbus out to the edge and see what happens. Oops. Okay. Yeah. All right, let's watch what happens with 5 turtles. All right.
And you can, like, if you want to dig in deep, you can find your own topological.
You can. So do you remember when you said what they do is they change? We have an extension. And we have an extension to that. Right. So but the default world is a little bit kind of weird. But the nice thing about something as basic as the shape of the world, but whenever you come to a main world, you need to do this kind of exercise. Okay. So we set about to go from file new and make things, and I think we should close out a little bit here and do time to patches. So let me show you some things about patches. So we were talking to turtles before, and we were talking to the observer. Let's talk to patches. So if I click on turtles and switch to patches, maybe, but in terms of like the reality of the world, it could be like some farmer cleared the grass, right? But that's gonna have an effect on the wolves that are, the sheep that are up on the right, right? If we did this one, what's gonna happen? All patches. What's gonna happen to the world? We think everyone's gonna die? So the grass grows, right? So it might come back in time, but it might kill everybody. So we don't know. These two could kill everybody or could not. So it's worth trying. What do you think this one does? We haven't seen this syntax yet, but you can read it.
Certain amount of sheep die.
100 sheep are going to die, right? So this is some disease that goes through the sheep population. Some disease that goes through the wolf population. What about this one?
Or reproduce.
So 10 sheep are just going to reproduce. How about this one? Each sheep is going to give rise to 100 sheep. How about just, we don't quite know what this is. We saw the energy variable before. What do you think is going to happen here?
So they become super sheep or super wolves, so the sheep reproduce at a massive rate, and then the wolves.
It might be that they reproduce, but at least we saw that the one thing that the energy did in that thing was if it got to 0, they died.
Yeah.
So this would be like immune, sheep that are immune to starvation or wolves that are immune to starvation.
Is the wolf's hunger factor related to their energy?
In fact, it's good enough factor. In fact, we should maybe look at that. But let's run some of these to see if we as kind of external players can do something to our stable ecosystem. So, for example, here I have got this world that takes long time, and it's been stable. So I'm going to do one of those things. I'm going to say ask. So I'm just going to go to patches. I'm going to say set color. All. Just only that was it. All. Right? It's a drought. It's a drought. And so you believe that all of them are going to die. Somebody else says maybe not. If they didn't all die, who would survive? And it would depend on what the time to regrow the grass was compared to the time, right? So we could actually figure out whether it's possible for sheep to survive or not. But I'm just going to try. Ready? 1, 2, 3, go. I don't know. That was I'm going to do it again. It's like it didn't even bother.
No, look, you got some spikes.
Oh, it definitely had an effect. And if I was an individual sheep, this would be a catastrophe, right? But for the population of sheep, it had a temporary wiggle, right? So the difference between if I think about it like a sheep, we were thinking, like we almost got two agents, right? We were saying, oh, we'll never survive that. But it turned out that the grass regrowth time,
We can now make this into the actual story.
the grass regrowth time is survive. If I made the grass regrowth time really long, which means that it takes 100 ticks for the grass to grow back, then they die anyway. Now that is crazy. While I wasn't sheep, but what it did was make this into a sheep paradise because it killed all the wolves.
I have an equal to mine, like the two years, like my wolves 32, it's not like you can change it. And the sheep 101. I feel brilliant. On accident.
Right. So one of the cool things about a model like this is that it's an authentic experiment. Like that is, I didn't know what was going to happen, but I killed all of them. Kind of less certain things can also work. So when we had this with high school students last year, we said, I did this, if distance x, y, 0, 0, less than 10, set. So if your distance from the origin is less than 10, you're going to turn blue. I'm going to make a lake. Now, it turns out that the code, when something isn't green or brown, the thing doesn't grow back, right? So I actually I get this permanent lake, but the sheep and wolves are like Christ like that.
There's a sheep waiting in your industry to come out of
In the winter, right? So in fact, but look, it's kind of awesome that the sheep are camouflaged.
There's not sleeping with wolves.
Yeah.
Because their faces.
Yeah, right.
So can I do
yeah.
one of my favorite
Yes.
experiments? So one of the things that I think is really cool about so I can tell you sort of I think we can sort of try and control what will happen. One of the fundamental ideas in ecosystems is obviously the food web, right? We have this idea of producers as having sort of energy that passes up through the system, right? So let's think about energy. So the other way is that sheep gains some amount of energy from that grass. Does that make sense? So basically the potential influx of energy in this system is some function of how long does it take for a ground patch to turn green, and how much energy is there potentially in that. Does that make sense? Just sort of at a certain point. So, right now, the regrowth time is 30, and sheep gain 4 energy from eating dead. So, what if we said that grass takes twice as long to grow back, but that sheep gain twice as much food, right? So basically, we were keeping it constant. We're keeping the amount of energy constant. Is anyone unsure why that is?
You change the grass into some long, more energy like corn.
Like corn, yes.
But
So the amount of energy going into the system is exactly the same with the populations. So okay, so I guess that there are a bunch of different things we can break it down into, right? So you say less. So less in general. So counting wolves and counting sheep and adding them up. For sheep, less. Does anyone? So does anyone want to add something? Okay, so let's
Okay, so one thing you said is number of animals, right? And we'll say set number of animals to a list.
Well, actually, what I want to do is sort of try and take an average for a little bit of time.
So we're gonna do this for a long time. We have like 9 minutes.
Right. So we'll say setup, and we will say just the variables, and then we'll run go for a little while. Okay, so this is with our old settings. Now we have this kind of list, and if we look at the meat of this list, then we see that we see. That's what you're saying. Server, mean, animals. Okay, so there have been 230.3 animals on average over the last 5,006. Okay? So let's try and do what we did before. We'll set it to 60, we'll set it to 8, and it is sort of about the oscillations. So are we going to see larger or smaller oscillations? Are we not going to see a difference? Also constructing, so we do that. Ends up looking pretty different, right? We saw sort of a pretty clear pattern over a long time, and now it looks like they're sort of they rarely cross. Right? The lines very rarely intersect at the top, and then we can see what they look like now. So it looks like we get more oscillations. What do you make of that? Do you make anything like that? So it'd be a long time for different distribution of what sheet you get through. And so because it's more scarce in one way, but it provides more energy, there are just fewer sheep who actually get to eat some of it. But the ones that do then stick around.
Does that mean you have a higher, you can't separate out like the difference between sheep dying from wolves and sheep dying from starvation?
We could make a new list, and then we could find, and sort of see if we can see a difference between those particular numbers that we can post this change.
Could also prove that like someone along eating sheep that are low on the energy scale, they get less energy per sheep, where you have like apex predator wolves who only have a fat sheep.
That's right, and actually in this model, the way that it's broken, they always get the same amount of energy for sheep, so you don't have conservation.
Yeah, so in fact, if you're going to work with a model, like collecting this kind of experiments to do it, open experiments are great.
Yeah.
What I wanted to do in the last 3 minutes, though, was have us actually do something. Arthur wanted to code that, but we haven't done the code that before. So we were doing things to mess with the stability of the model by doing these in the command center. Let's see what happens. Does is unpresses the go button and everybody's dead. If you've ever gotten a station, you see the model stops. This is our rule. This is our rules about grass, and this is some maintenance. So basically, if we wanted to understand how sheep work or how wolves work, we would just look at this bit of code and unpack it. Now it's not going to be super simple because some of these things are defined. But let's just look and see if we can understand our read. So we're going to ask the wolves, first thing they're going to do is move. And move, if you didn't know this model, you hadn't played with it, you might think it meant a hunt or like a chase. Turns out it just means move like those turtles in that first example. It's kind of a one. Then they're losing energy from moving. They're trying to catch sheep. They're maybe dying, and they're maybe reproducing if they don't die. If they die, they can stop moving.
All the wolves will die.
Actually, what kind of thing are going to move?
The wolves and sheep.
Say it again?
Nobody would die because they only lose energy when they move, right?
They lose energy on the next line.
Okay, then they all die.
They're going to die? What did you say? If the sheep ran into this.
So like carnivorous plants.
Right, so let's see what happens if if I do that. So in code, in NetLogo, I commented out this line, which means it's now not going to be used. But if I run this thing, now the wolves are just sitting there, and if a sheep runs into it, it eats it.
So, the wolves, when they reproduce, they're reproducing in different patches. Is that a natural, like...
They're reproducing on patch right next to it.
So, but that's the thing, is that wolves can't cohabit on the same patch?
They can. No, they can't. The logic of reproduce, you'll see that it.
Oh, okay.
So if you hatch, if you just use hatch, you get an exact.
You would have like a.
right on top of it.
You have a mountain of wolves on top. If I say, ask wolves, set shape, I've got these black flowers, and I ask the sheep, set shape, sure. Now I've got this ecosystem of Venus flytraps and it has some of the same properties of the wolf sheep thing. So if I wanted to change wolf sheep into Venus flytraps flies or whatever, I would probably want to go into some of these sub-rules and make them more logical. But I can use wolf sheep as a starting point for the next one. Like, I don't like that I don't have so many Venus flytraps. Maybe what I should do, how would I make it there be more Venus flytraps sustained here? Like, how would I make it better for flytraps? Which of the sliders would you change?
The reproduce slider?
I can make them more likely to reproduce, but that might make them die because they cut their thing in half, right? What else could I do? Increase the number of bugs, right? I could do something with the grass, with the way the bugs are gained from food. So I can make this wolf gain from food super high. And then maybe they would proliferate because the ones that happened to fall into them gave them much more energy. But I just wanted to show that, like, even something stupid as cutting out lines of code can be a creative act. Sometimes you can learn about the model by, I cut this line of code out and everything fell apart, right? So that was like a really critical one. But here, I've got an ecosystem which has very different properties from just having subtracted one line of code. And I think it's really fun for kids who are learning about coding to learn a lot by modifying, taking apart, hitting it when it's down, etc. Before we leave, I wanted, since we got absorbed in NetLogo, we didn't do anything about NetLogo. I wanted at least to bring you to the page.
Your project's kind of running with that.
Right. Oh, by the way, while we were talking, I got a note from Wilensky, the inventor of NetLogo, who said, "How's the workshop going?" So what should I?
Send him Sophie. Or send him sing him my heart will go.
So if you go to the website, if you go to the workshop website,
I'm almost certainly got. Okay, let's see.
Isn't it like when yourself is you can see the screen while you're...
Yeah, but it's not as good that much.
It's good, yeah.
So let me show you this one thing. So if I go to the NetLogo webpage, in NetLogo, I can click on this button and pull up the model into NetLogo web. So you can use NetLogo as an authoring environment for NetLogo. I pull this model up, and it says, it gives me some some somewhat unexpected things. But I will get